Now for the wonderful world of access lists. Access lists are used for managing traffic. Access lists are not for security. Sometimes that point can be sort of confused because they seem to offer some form of security. But the reality is, access lists are designed to manage traffic. Different applications of access lists include the fact that we use access lists to filter or control traffic moving through the router, but not originating from the router. Three particular uses of access lists include: 1. We can use access lists for priority or custom queuing. 2. We can use access lists to specify interesting traffic with DDR, or dial-on-demand routing. 3. We can use access lists to filter certain routes from our routing tables. There are two types of access lists: standard access lists and extended access lists. Each one of those access lists filters based on a different set of criteria. Standard access lists filter based on source address only, whereas extended access lists give us a bit more granular control. Let's take a look at the packet format, the encapsulation itself, and see how standard access lists work as opposed to extended access lists. Here's an example of an encapsulated data frame. Notice the upper layer information was data. It was encapsulated into layer 4 as a segment. Layer 3, there's a packet header. Now it's a packet. For instance, using a protocol like IP. And then layer 2, there's the frame header itself, using HDLC or Ethernet or something like that. Standard access lists filter traffic based on source address only, the source address in the IP packet only. Standard access lists also filter the entire protocol suite. So if a particular packet is coming from device 10.1.1.1 and going to any other device, the access list, if it matches that particular address, will filter all IP packets coming from that source address. Extended access lists, however, filter based on the source address in the IP packet as well as the destination address in the packet. Also, extended access lists filter based on the particular protocol that's used in the IP packet, such as TCP or UDP, ICMP or ARP. But in addition to this, extended access lists go further into the layer 4 information and can filter based on the port numbers as well. So extended access lists give us more granular control over the traffic that we're filtering. Let's take a look at how access lists filter packets as they're coming into and out of the router. Here we have an incoming packet coming into the router. The router compares the destination address of that packet to its routing table. If there's an entry in the routing table, the router then selects an interface for that packet to be sent out of. After selecting the interface, the question is asked, is there an access list on this interface applied to this interface? If there is no access list, the packet is simply sent out of that interface. However, if there is an access list, the access list is checked. The packet is compared to the different lines in the access list, the different list of tests in the actual access list. If there's a match to the first line and it's a permit, then the packet will be sent. If there's a match to that first line or the first test and it says deny, then the packet will be dropped. If there is no match to the first line, the packet is compared to the second line. If there's a match there and it says permit, the packet's sent. If there's a match and it says deny, then the packet will be dropped. If there is no match to that packet in that particular line, then the packet will move to be compared to line 3. If there's a match and it says permit, it's sent. If it says deny, it'll be dropped. If there's still no match after all of the different lines in the access list are compared, then the packet is compared to the final line in the access list, which is a line that you can't see, which we don't configure, but it's there by default, which is referred to as the implicit deny all. That packet then will be matched to that particular line in the access list, and that packet will be dropped. So if there is no permit statement in the entire access list for the packet, that packet will be dropped. Access list numbers are used to specify the protocol that's being used and the type of access list it is, whether it's a standard access list or an extended access list. Let's take a look at the comparison between the different access list numbers. For IP, a standard access list number would be numbers 1 through 99 or 1300 through 1999. These would be standard access list numbers. So when you're configuring and if you select one of the numbers from one of these ranges, the router knows that this is a standard IP access list. Extended would be number ranged 100 through 199 or 2000 through 2699. And then you could have a named access list, which we simply give it a name. Usually we use named access lists for the purpose of being able to specify the particular purpose of that access list and maybe where that access list is being applied. Inside the named access list, you can configure whether it's going to be standard or extended. There are different access list numbers for the different protocols, but for our purposes here, we simply wanted to cover IP. So there you have it. Access lists are used to manage traffic as our network grows.